In this video, I would like to derive an equation for the number of the beats that occur per second when observer is crossing a source that is stationary. Let me tell you what's the meaning of that. A source is in the state of rest like a horn. You are the observer moving with a bike towards the source and you have crossed it. Like it's a traffic post with a constant siren. You are approaching the traffic post and then you are leaving the traffic post and you are the observer. When, so you are talking about a case when observer crossing stationary source. There are two things happening here. He is approaching in first case and he is receding in the other case. So when approaching, when observer is approaching the case, that is this case you're talking about, this part, it's an equation we can write. N dash apparent frequency is V plus VO by V into N. As I told you, source is in the state of rest, so denominator we have only velocity of sound. Observer is in motion, so numerator will be get affected. In the first case, observer is approaching, so apparent frequency is more, so plus has to be written. Now let's talk about the second case. When the observer is going away from the source, when he is receding, when observer is going away from the stationary source, apparent frequency is less, so V minus VO by V into N, the same observer, the same value. So this N dash and N double dash are not equal, they are different. It's very clear that N dash is greater than N double dash. So certain number of the beats are generated per second. So how many beats are generated per second? You know the number of the beats per second is bit frequency. That is nothing but the difference between the frequencies. As N dash is more, N dash minus N double dash. N dash is V plus VO by V of N minus N double dash is V minus VO by V of N. Right? For both of them, N by V is common. V plus VO in the first term minus V minus VO in the second term. So that is equal to N by V of V plus VO is a minus. So minus V, minus of minus becomes plus, plus VO. So V and V will get cancels. VO and VO, 2 times of velocity of observer by velocity of the sound into N is the number of the beats generated per second. You can substitute in a problem while you are solving this formula and solve it, right? That's when observer crossing stationary source. But there is another case. When source crosses the stationary observer, how it happens? Let us try to understand what that means, right? So I have done already the first case, observer crossing a stationary source. Let's talk about when source crosses stationary observer. So let us consider a observer in the state of rest, like you are a traffic person waiting in the traffic post, like a traffic constable. Another source, like a car, is approaching you and then going away from you. What is the beats heard by you? Being a traffic constable is the question that is being asked here. So what we can say? First, the source is approaching, then you will have a frequency N dash as V, no observer motion, so numerator is only V. As the source is first approaching the observer, apparent frequency is more, so denominator is less. We have derived all these equations. This is N dash. While he is going away, N double dash. As the source is going away, apparent frequency is less now. So V plus Vs into N. It's clear that N dash is greater than N double dash. So the number of the beats per second is difference in the frequencies, N dash minus N double dash. N dash is V by V minus Vs into N minus V by this value, V plus Vs into N. So V and N is common for both the equations. 1 by V minus Vs minus 1 by V plus Vs is the thing that we need to solve. This is A minus B, this is A plus B. So the denominator is A square minus B square. So the numerator of the first term will become V plus Vs minus second term becomes V minus Vs. Let us simplify this a little further. Yeah. B per second is V into N is common. Denominator is V square minus Vs square. This is V plus Vs. There is a minus sign. So minus V, minus of minus becomes plus Vs. So this velocity of sound gets cancels. So the number of the beats per second is velocity of sound and velocity of sound. Source 2 times velocity of the source to velocity of the source into V. The denominator V square minus Vs square of N is the beats per second. That's the equation. You can use that equation directly, but we can make a little correction further. What is that correction is? We know Doppler effect is valid only when the velocity of the source and sound is less than the velocity of sound. So velocity of source and observer is less than the velocity of sound. So if you square that, it becomes even less than that of, much less than that of the square of velocity. So when compared with velocity of sound square, this velocity of the source square must be very small, and you can approximate it and neglect it. Then beats per second. Now approximately. Remember here, see, I have written equal, but here I am writing approximately. 2 Vs into V by V square minus, I have ignored this term now. I am writing it as 0 and N. One velocity of sound and velocities can be cancelled. So beats per second approximately can be written like 2 Vs by V into N. I want you to observe one thing carefully. When observer is in crossing position, you got an answer as 2 times of velocity of observer by velocity of sound into N, who is a perfectly accurate equation. But when source is in the state of motion, you got an approximation as 2 times of velocity of a sound by velocity of source by velocity of sound into N. So if you notice little carefully, these two equations looks like same equations. But the first case, when the observer is in motion, that's the most accurate equation. But in the second case, when the source is in motion, that's not that accurate. That's the approximation. That's the point that I want you to observe little carefully. That's it. Thank you for watching.